Alright, here is the video guide for lesson 2.1.2, angles formed by transversals. So here is another lesson that's going to focus in on angle relationships. We saw 3 angle relationships in 2.1.1 and we're going to add some more to that here today. Okay, we'll start off, and the first few problems are just a review of the angle relationships that we saw in lesson 2.1.1. Okay, so in 2.1.1 we saw supplementary angles, we saw complementary angles, and we saw vertical angles. And so take a look at these first problems, and I have multiple choice here. Just give me what do you believe it is? What kind of angle relationship exists there? Okay, so there's that problem, this problem, same kind of thing, and then a third problem, and even a fourth problem. Again, talking about angle relationships, and really going back to those 2.1.1 relationships that we hit home in the first lesson. Now it's starting to get more into this lesson, some newer stuff, and what we have here is this idea of Markos tiling pattern. Okay, now we don't really need to use the E-tool, but the E-tool kind of shows us how this was created, this tiling pattern was created, so we'll take a quick look at that. And really all that's happening is you take a parallelogram and you slide it around. So it's always touching one side of the parallelogram before it. And this tiling pattern starts getting created, and you can see that all these parallelograms, individual parallelograms, are the same. So we'll go from there. We see here what they want us to do is determine which angles have the same measurement, and then we want to color those angles in. And so a good one here, and we know this from lesson 1.3.2, parallelograms have angles that are the same right here and across from each other, or what I said was opposite of one another. Okay, so those two are the same, and these two are the same, and we want to draw those all over this tiling to see how those angle measures, how those angle relationships look in this tiling pattern. Okay, so then you'll draw that out and you'll answer the 2 questions here for A and B to the best of your ability. Next, it'll have us draw lines, which lines are parallel in these tiling diagrams. Okay, and so we can kind of see it. It's a little tough, so I'll draw a couple out here. This line here is parallel to this line here. And we have other ones in there. So color which lines are parallel to each other. You know, I did blue for those two. Well, if there's other parallels, you might need to use a different color to make sure they stand out. Here, you can see the connection here. If we look at the picture here, we're focusing in on this tiling pattern. Okay, you can see we're focusing in on a certain section of that tiling pattern, and it's going to introduce this new word to us. Okay, so this line that's cutting through these parallel lines is what we call a transversal. Okay, so it says in this diagram down here, which line is the transversal, and I'm going to give you that answer because we've never really seen this before. It is line JK. Line JK is the transversal because it's cutting through those parallel lines. Okay? If there's more questions, read the questions closely, make sure you're paying attention to vocab, and answer whatever they are asking us. Okay? Because it says, I got the transversal one answered, but it also asks what lines are parallel. Make sure you state which lines are parallel in the diagram there. Moving on, we have a big vocab word here. So we talked about some angle relationships in 2.1.1. We talked about supplementary, complementary, vertical angles, and now we have corresponding angles. And so what they say is angle X down here is corresponding to angle B. And if you go back to the colored angles here, what they're really saying is that these 2 angles, this blue angle right here and this blue angle right here, are corresponding. Okay, so we go back ahead. And then it says, what is the relationship between them? And if you look back on that slide, you can say what happens. You know, is one greater than the other? Do they have to be equal? And if they have to be equal, explain why you know they have to be equal. Think about that Markos tiling and how each parallelogram was exactly the same, just slid up or slid down. And we know from chapter 1 that when something is just slid, that it's just a rigid transformation. The angles and the sides don't change. So keep that in mind in your explanation. Moving on, we're going to keep focusing on corresponding angles. And so it's saying, well, B and X were corresponding. what other corresponding angles exist in this diagram? So it tells you in the problem before that B and X correspond. Which other ones do? Okay? Which other ones do? Now, the other part of this problem is going to tell you, well, B has a measure of 60 degrees. Now, using supplementary relationships and using vertical angle relationships and using our corresponding angle relationships, we should be able to find out the measure of A, C, D, W, X, Y, Z. Now, this is a great problem, one that we'll see again, but this is one that I want you to try, and if you don't understand it, please ask for an individual video or ask for help, because this is something we need to understand here in Part B. Making sure, okay. Going on to 12 here, we're using our relationships again. You can see two parallel lines getting cut by a transversal. Two parallel lines cut by a transversal means we can use our angle relationships, especially like supplementary, especially corresponding angles, because that's really the case that they come up in. Okay, so use those relationships to find X and Y and go from there. Okay, again, an important problem because we'll be doing a lot of these. Make sure you ask questions if you are stuck. Here, determine if we have enough information to find X and Y. Now, this one might not have an information because we don't have parallel lines, and we know for it to be a transversal needs to cut through parallel lines. So if you can find an answer for X and for Y, try to. If you cannot, then there's a possibility that there is no answer. Here we're back to having parallel lines. It looks a little different, like it maybe was rotated 90 degrees, but we have parallel lines cut by a transversal. Try to answer for X and Y. Here, again, same kind of problem as the last ones, all 217s. Again, try to find X and Y if you can. If you cannot, then just write not possible. All right, now we're going to kind of reflect on 217 and say corresponding angles always have equal measure, or do they sometimes not? All right, in the right circumstance, we got to kind of say, like, if this is the circumstance, then this is going to happen. And that goes into this second part here with what they call a conditional statement, an if-then statement. All right, in an if-then statement, a conditional statement, you say if blah, 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 if this is the case, then blah, 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 then this is the case. So theirs is if blank, then corresponding angles have equal measure. So we need if something, then corresponding angles have equal measure. Okay, and really fill this one out, because writing that conditional statement can really stick with us, and it'll help us remember when do we have corresponding angles, and it helps us remember the right situation to use them. Here we have our kind of challenge problems. So we know our angle relationships at this point, we know our definitions, and they're going to challenge us here to really work and use all of them. So looking at this diagram, you know X is over here, you know 115 is over here. Somehow you have to try to use the fact that that angle is 115 to solve what X is up there. In some situations it's not possible. I will say in this situation it is possible. Okay, so it is possible. There is an answer for X, and try to find out what that is. The next few are like that. You'll have the diagram. You'll have to solve for X. They are kind of challenging. I think we all can do it though if we work hard through the lesson. And then again though, it'll say in here, if possible. So make sure you're looking and reading those directions, because if it's not possible, you can write not possible. But make sure you try your best and say, like, I've tried everything, it's clearly not possible. And then lastly, the last one we have here, again, if possible, you need to find find the relationship that you can maybe set these equal to each other, or maybe you could add them and set them equal to 180 if they're supplementary to one another. Okay, so make sure you try to figure out, well, how do these angles relate, and how can I then use that to solve for X? Okay, this is a tough one. If you get here and you're stuck, this is one that I love to make a video for. All right, so please ask questions throughout the lesson, anything. This lesson 211 and 212 are extremely important in Chapter 2, so please, please, please ask those questions if you have them.